In the last video, we finished up our enter function right here. Whenever someone calls the enter function, we take their address and we add it to this array of players. And remember, the players array is a list of addresses. I think we're now at a spot where we can test this contract out inside of the virtual network that's running inside of our browser. So on the Run tab up here, I'm going to find the environment dropdown here at the top right hand side, and I'm just going to make sure that it says JavaScript VM. Remember, this makes sure that it's going to use the network that's running inside of the browser. Then a little bit lower, I'm going to make sure lottery is selected, and I'll click the Create button. That creates a new instance, which we see appear down here. Now we can immediately double check to see that the manager was set correctly. We did this once in the past. You'll notice that I have address CA35, and if I go back up here to the account that I used to deploy that contract, yep, it's CA3, presumably 5 after that as well. Now the next thing we'll probably want to do is use the enter function. So this should add us to the players array. So I'm going to click on enter right here. You'll notice that nothing really appears to happen, except we definitely do get a little pop-up over here inside the console. If we want to, we can try to access the array of players by using the players button right here. Remember that by default, whenever we mark an array as public, that means that we can only access one element at a time. We don't get returned the entire array. If we look at the first element inside this thing, we should see our address appear. So the first element is going to be at index 0. So then I'll click the button, and sure enough, we see again CA35. Now I'd really like to test to make sure that we can enter on other accounts as well. So I'm going to go back up towards the top. I'm going to find the account section, and I'm going to change my active account to the next one down on list. Now I'll go back down to the bottom. I'll click enter again, and now we should be able to update players to index 1, and we should see the next hash, or the next address, which is 1472, and if I look back up here, yep, it's 147. So we're definitely now recording the correct address for everyone who is attempting to enter the lottery. However, our lottery definitely has a big problem right now. Remember, the lottery pool consists of all the money that the players send into it. So if player 1 and player 2 send in 0 ether, then there's really no money to be won. And what's the point of the lottery then? So I think that we need to somehow enforce a rule that if you want to enter into the lottery, you have to send in some amount of money. Luckily, as you might guess, this is something that is rather easy to do with Solidity and Ethereum in general. So here's what we're going to do. Right inside of our enter function, we're going to add another function call. This is a global variable, very similar, or a global function, very similar to the MSG one that you see right here. The function that we're going to call is require. Require is used for validation. We can pass in some type of Boolean expression to this require function. If that Boolean expression returns to false, then the entire function is immediately exited and no changes are made to the contract. If the expression evaluates to true, then code inside the function continues to run as usual. So the require function is a great thing to use to make sure that some requirement has been satisfied before allowing the rest of the function to be executed. In this case, I think that we should probably make sure that if someone is attempting to enter the lottery, they should be sending along to this enter function right here, maybe some minimum amount of ether. So inside of the require statement right here, I'm going to add in message, because remember, MSG is how we get access to the transaction that is coming to this function. And then to get access to the amount of money that this person is sending, we can reference the value property on that. And recall that we spoke about this MSG property just a moment ago in this diagram right here. So we have already made access to the msg.sender property. Now we are using value as well. And this is the amount of ether in way specifically that was sent along. Now we definitely want to make sure that these people send along some minimum amount of money. So I'm going to check to make sure that at least 0.01, and I think probably 0.01 ether is a good place to start. Now remember, like I just said, this is going to be the amount of money in way right here. So rather than putting in 0.01, we might have to convert this to 0.01 in way. Well, here's our ether converter right here. So if I enter 0.01 ether, then this is the amount of way that we want this person to enter. Now, of course, if I take this number right here with all these zeros and put it into my contract like this is not very legible, right? It's really tough for you and me to look at this number and have any reasonable sense of what the minimum amount of money is to enter into the contract. Fortunately, there's a little helper to allow us to not have to write out these large numbers whenever we are trying to specify some amount of money. So rather than writing out this big number, we can write out simply 0.01 space and then ether, like so. When we write out ether right there, then this number will get automatically converted into the appropriate amount of way. So by writing out this statement in total, we're going to ensure that whoever is trying to enter into our contest is sending along at least 0.01 ether. Now, of course, you and I could definitely make this like 1 ether or whatever we want, but hey, remember at some point we're going to be using our xbte test account to test this thing, and we only have like 18 ether right now or so, so we don't really want to be spending 1 ether at a time. For testing purposes, it's a lot nicer to just be spending like 0.01 at a time. Okay, so this is looking pretty good. Let's now test this out by redeploying our contract. So over here, I'm going to find the existing lottery contract that we deployed. I'm going to delete it. I'm going to swap back to our CA account up here, and I'm going to create it again. All right. Now I'm going to open up my console over here, because if we attempt to call the enter function without paying in the correct amount of ether, at least 0.01 ether, I'm going to expect to see an error message. I'm going to want to see something that says, hey, someone tried to call this function, but they did not meet this minimum requirement. Now, we haven't spoken about sending along money to a function yet. If you scroll back up to the top on the right-hand side, you'll see this section that says value right here. So this is how we send along some amount of ether to a function call. So I'm going to specify 0.011, because notice how this is greater than 0.01, so we need to be greater than 0.01. And then I'm going to change it over to ether in the drop-down right here. Then I'll scroll back down to our deployed instance right here, and I'm going to click on enter. So this should have successfully entered me into the contract. If I look at the players array, specifically index 0, and then click on the button, yep, I definitely got entered in. So let's now see what happens if we attempt to enter into the lottery without sending in the correct amount of money. On the left-hand side, I'm going to clear the logout, and then back up here, I'm going to try entering on the other account. So I'm just going to select any other one. And then this time around, maybe I'll try to enter with 0.00001 ether. So I'm definitely not meeting this minimum requirement anymore. So now down at the bottom right-hand side, I'll try to enter again. And very quickly, you'll see a big error message appear right here. So the error message says, transact to lottery.enter occurred, VM error revert. The transaction has been reverted to the initial state. So clearly, this require statement did its job, and it made sure that if we did not meet this minimum requirement, that we would just get kicked right out of the function. Now here's another gotcha. There's a lot of gotchas around Solidity, and here's another one that I want to mention. As soon as you start using these require statements, you're going to see error messages that look like this down here. I want you to notice that we have no information inside this error message that seems to indicate that we did not pay in enough money. So when you start using require, if your require statement fails and you get kicked out, that failure does not clearly get communicated back to you. And this ends up being a little bit of a pain when you're doing development of your contracts, because you might eventually have your function calls failing, but there's no clear message to tell you why it just failed. Again, this is just something I want you to be aware of, because when you start developing your own contracts, you'll see this error message right here, and you're going to start saying, wait a minute, I thought that was working. Why is it not working anymore? And there's nothing that's going to really draw your attention to require right here. Okay, so in this video, we learned about the require statement right here. We're going to be using require quite a bit throughout the rest of this contract and the next one that we work on as well. So we'll get a lot of experience with it. Let's pause here and we'll continue in the next video.